Hello everyone and welcome to our universe. Today we'll be talking about types of supernovae. So supernova are pretty much everywhere in the universe, probably apart from the Milky Way, where it seems to be quite scarce in the last millennia. But regardless, supernovae give us a great insight into the life of stars and the evolution of galaxies. But supernovae are basically categorized by astronomers in different ways. They're not just one big massive explosion. There's different types of them. So supernovae are categorized by letters and numbers, and these categories are defined in the brightness and dimness of a supernova, and also which elements are detected in the light of the explosion. The first method is caused by a white dwarf in a binary system. If the companion is very close to the white dwarf, when it enters the red giant stage, its outer layers can be pulled off by the white dwarf. If enough matter is transferred from one star to the other, the mass of the white dwarf will continue to increase, until it reaches a critical mass. At this point, the white dwarf is too massive to be stable, and therefore it explodes in a violent supernova. This is what's known as a Type 1a supernova. This always occurs at this critical mass. This critical mass is about 1.4 times the mass of our Sun, and therefore the brightness of the supernova is very predictable. So the most recent and nearby supernova of this type occurred in a spiral galaxy called Messier 101. This lies around 20 million light years away, so it's not a very close galaxy. It was first observed in August 2011 and was quite visible to small telescopes for weeks after the explosion. Another type of supernova explosion takes place when a core of a massive star runs out of nuclear fuel. At this point in the star's lifetime, the core of the star is mostly made of iron, with layers of lighter elements on top of it. When the star's nuclear fusion ceases, the outward pressure has a sudden drop, which means that the gravity of the star slowly increases, and the star starts to collapse in on itself. This type of supernova is more of an implosion rather than an explosion, although to be honest, the material then rebounds off the dense core and is flung out into space. This is what's known as a Type 2 supernova, although if you observe a star that seems to have a hydrogen envelope of layers around it, you can often call it a Type 1b or a Type 1c supernova. The second type of supernova only seems to occur to stars that are 8 to 9 times the mass of our Sun. If a star has a mass of 20 to 30 times the mass of our Sun, the remaining material will be so massive and so dense that it could form a black hole. But you can even get stars that are even more massive. You can get stars that are about 40 to 50 times the solar mass, and these will definitely form a black hole instantaneously. And usually they won't even produce a supernova at all. And of course for astronomers, these are very hard to detect. But regardless, supernovas are very important to astronomers to understand the lifetime of stars, black holes, galactic evolution, and the early stages of the universe itself.